Good evening all. I think class is going good. Okay, fine. So yesterday what we saw in the last class, we designed multiplexer, right? So next we are going to design demultiplexer, right? So that is our next task. First let us design demultiplexer. Already I told you the purpose of demultiplexer is it's very simple. It is going to distribute the data, right? So it is going to distribute the data, right? So first let us design the multiplexer, that is a demultiplexer quickly, right? What is the difference between multiplexer and demultiplexer? So let us see. In demultiplexer, the number of input line is always 1, whereas the number of output line is 2 power n. Okay, right? So let us see how to design the demultiplexer. So the general structure is, anyway, in multiplexer and demultiplexer, apart from input and output, we are also considering few more people, that is one more person, that is called what? Data selector, right? So in the output side, we are going to consider 2 power n output lines. So this is our output of the demultiplexer, right? In general, always input line is fixed as 1 is to 2 power n, right? So let me consider input line is data line, let us consider. And whereas this is our enable pin, right? So that is called data selector, right? So here you can consider n number of input, right? That is n number of data selector, right? So based on the input and output that we are going to consider. Okay, fine. So that is the general structure of the demultiplexer. Let us design. First we are going to design 1:2 demultiplexer. It means I'm just considering n equal to 1, right? If I'm considering n equal to 1, then I can say directly the another relation is how many output lines should be required? 2 output lines, whereas how many input lines? Only 1 input line, right? So this is the input line D. Let me consider, whereas the number of selection line is, so see there, in order to produce 2 outputs, I need of 1 selector line, that is 1 data selector. So let me consider only S0, because at S0 equal to 0, automatically output, right? In the output side, let me consider 2 output pins, Y0 and Y1. When S0 is going to be 0, automatically Y0 will be enabled. When S0 is going to be 1, automatically Y1 will be enabled, right? So we are going to distribute the data for various people from the at the receiving end, right? So the collected data will going to be distributed, right? So for different people. So let's see how we are going to receive the output here. So Y0. Now what will be the Y0? At S0 equal to 0, data will be selected. Once again, I would like to write this term in SOP format, that is S sum of product or min term. In min term, usually we are not allowing zeros, right? So if S0 equal to 0, right, I have to take a complement for S0 and then it should be multiplied. Your selected data will be distributed through Y0, like our distribution transmission line, right? Now when we are setting S0 equal to 1, automatically second line will be enabled and your input will be passed through Y1, such that S0 is, we are considering S0 equal to 1 only now, so 1 is acceptable. So S0 into D, so your data will be that is passed through that is Y1, right? So let us consider n equal to 2. If I will consider n equal to 2, then what happens? Let us see. Let us increase the number of output lines. Anyway, you can increase the number of output lines and the corresponding data selectors, but you cannot increase the number of input line, right? So the input line is fixed in demultiplexer, right? Such that, let us see, if I am considering n equal to 2, then what we are going to get? The output when n equal to 2 is going to be, let us see, once again, 1 is to 2 power 2, right? n is to 2, that is 1 is to 2 power n is called a demultiplexer. When I am considering n equal to 2, automatically 2 power 2 is going to be 4. That is called 1 is to 4 demultiplexer, such that input line is 1 once again, whereas in the output we are going to receive 4 lines, right? So let us consider Y0, Y1, Y2, Y3, such that here in order to supply 4 people, I am in need of 2 data selectors S0 and S1. Let us consider there are 4 combinations. When S0 and S1 are going to be 0, Y0 will be enabled. When it is going to be its combo, there are 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1. So totally we are having 4 possibilities. When both are going to be 0, automatically output Y0 will be enabled and its output is going to be data selected D with since we are writing in SOP form, that is min term. In min term format, 0 are not acceptable. So we should take complement for that, such that we should raise S0 should be considered. This we should take complement for S0 as well as we have to take complement for S1 also. Now let us consider Y1. Now when we are considering Y1, so we should consider 0, 1 as the combo. Anyway 0 is not acceptable. So once again consider data selector with 0 is not acceptable. We should raise S0 complement, right? And then we can consider, you can accept S1, there is no changes. Similarly let us consider Y2. Now white in the sense 1 0. Now data selector once again 1 is acceptable, so directly we can consider S0, but 0 is not acceptable, we should take complement. Now the final data line will be selected when S0 and S1 are going to be 1 1 such that output, right? So the data will be distributed through the fourth line, whereas its correspondent data selectors are going to be S0 and S1 only simply. So if you want to implement the circuit, you can simply implement, right? So let me also show you the implementation of the digital circuit, right? So in order to implement the digital circuit, let us see the implementation of the circuit, right? So let us simply observe the implementation of the circuit. Now in order to implement the circuit, actually we are going to receive 4 outputs, right? For that we need 3 lines. So let me select. So first let us consider data line from the input side. With this we are going to consider 2 more lines. The 2 more lines are called what? Data selectors. So let me call them S0 and S1. Let us receive the output from them. First Y0. Y0 equal to what? D into S0 bar into S1 bar. See, this is S1. If you want to take complement for this, just take the inversion of S0. Similarly, S0, S1 both are being inverted. So I am considering NOT gates, right? So then you can connect it, right? With this I'm in need of a data selector. Let us try and connect this one also, right? So that is going to be the output value of Y0. Clear? Now similarly you can also draw Y1. If you want to receive Y1, S0 bar into S1 into D, right? So D, once again let me select a line from D, right? And then let us consider one more line, that is S0 bar. S0 bar in the sense, either you can take, see there, S0 bar in the sense already this S0 is being complemented here. You can directly select a line such that one one logic gate will be reduced here, cost will be minimized. Anyway, for your understanding I am putting this one separately. Similarly we have to consider S1, right? So for S1 we don't need to take any complement, so directly let's join all these people together such that your output is going to be Y1. Now let us consider third one, D into S0 into S1 bar, right? So D data selector, and next one is S0 into S1 bar. S0 I am directly selecting from here. S1 bar, guys listen. Usually in your textbook at all, usually you can see S0 இங்க இருக்கு அப்படினா S0 ஒரு லைன் போட்டுருக்காங்கன்னா இதுக்கு parallel என்ன பண்ணிருப்பாங்கன்னா directly they will select one more line like this, because each and every time I need to consider separate inverter for this. It is waste of cost, na? So they won't like that, they won't implement the circuit like this. This is the actual way of implementing, but that circuit is not looking like fair, that's why I am going like this. Okay, don't think that I am wasting money. You have to keep these things in your mind, right? I am not wasting the money, I am just for your explanation I am putting like this. You can separately keep one single inverter like this, and then this is S0 bar, this is S0. So whenever you want S0 bar, directly you can select a line from here such that your cost will be minimized. Okay, fine. So let's continue our journey with this. So this is going to be what? Anyway, data selector S0 into S1 bar will going to give you the value of Y2, such that you can also implement the final circuit. I don't know whether the bottom portion is visible to you all. Let me check it by myself. Yeah, that is visible. That's good. Let's continue. Finally we are going to select a data selector from here. Let me select, and then one more line from here, of course. So let us join all these people together, and this is going to be Y3. Clear? So this is the output. That is how we are implementing the given logic circuit, that is 1x4 multiplexer. Clear? I hope things are very clear to you all. In the same way we can also design what? 1x8 multiplexer, right? So in the same way we can also design 1x8 multiplexer, and you know how to do that one, right? So anyway, for your understanding, let me show you how to do that one also, right? 8x1 multiplexer in the sense we need 3 combinations, right? So from the data selector I should select 3 lines such that I will be able to draw the complete circuit, right? At last we will see the implementations. By using small circuits we will realize the big circuits. Okay, we will see how to do that one also. So let us consider the next one is, let me raise the number of input as n equal to 3. If I raise number of input n equal to 3, then what shall we do now such that its combinations are going to be? Let us consider input line. From the input line we are considering only one single line, that is 1, and the output line n equal to 3 in the sense 2 power 3 is going to be 8 na. Yes, so how many data selectors should be required for this? 3 data selectors should be required for this, right? So from the input line we are going to consider only one data line, and whereas here you are supposed to consider 3 lines, s0, s1, s2, such that in the output side y0 we are going to receive y0, y1, y2, y3, y4, y5, y6, y7. Totally we are considering 8 lines. So y0, let me consider y1, let me consider y2, y3, y4, y5, y6, y7. Right? Let us see the outputs of the function. When s0, s1, s2 all are going to be 0, automatically y0 will be enabled and its output become d into s0 bar into s1 bar into s2 bar. When these three people are going to be 0, 0, 1, automatically y1 will be enabled. So data d, and this is 0, s0 will be 0, that is 0, 0, 1. Clear? Next y3, this is going to be selected when we are considering 0, 1, 0, 2, right? So 0, 1, 0, 1, 0, right? So we should take that is 0, 1, 0. Next we have to consider 0, 1, 1, 0, 1, 1. Next we have to consider data selector. We have to consider 1, 0, 0, 1, 0, 0, 1, 0, 0. Now we have to consider 1, 0, 1, 1, 0, 1. Next we have to consider, so let me clean this one. So 1, 0, 1, 1, 1, 0, 1, 1, 0. Finally we have to consider 1, 1, 1. So s0, s1, s2. So that is how we are designing 1x8 multiplexer, right? So I hope things are very clear to you all. So demultiplexer is also very easy. But now the thing is how to realize the different types of multiplexer just by using a single multi. That is, let us consider 1x2 multiplexer. Let us see how to implement. That is, how many 1x2 multiplexer are required in order to implement 1x4 multiplexer, right? So this procedure is same as our multiplexer already we saw, right? Let us see the implementation of various multiplexer using 1x2 multiplexer. First, the example is question number 1. The question is we have to use 1x2 multiplexer and we have to demultiplexer. Sorry guys, I'm murmuring. I'm sorry. That is 1x2 multiplexer, demultiplexer, and we have to inverse. That is we have to design 1x4 multiplexer. Now the formula that I had given already. In order to know the number of gates, number of demultiplexer, in order to know the number of demultiplexer, the general formula what I've been told you, which gate that you are going to implement divided by which gate that you are going to use for that. You should just take the ratio of the 2 power n. 2 power n in the sense here 2 power n value is 4. Here 2 power n value is 2. Such that if I'll take the ratio between them, so implementation is 4. We are going to use 2. Right? If I'll cancel this one, in 4 we have 2 na, right? So okay, that is remainder. That is I can cancel 4 by 2 times. You can take the 2 again. You will have to divide by 2. So if I can cancel it by 2. That 2 again can be divided by 2. One more 2. Such that what is the answer here? We are going to get 2 plus 1. So totally 3 1x2 multiplexer should be required in order to implement 1x4 multiplexer, right? So let us design, let us see few more examples. Now let us consider 1x2 multiplexer only, but now the question is 1x64 multiplexer. Now the question is identify the number of 1x2 multiplexer should be required in order to implement 1x64 multiplexer. So what shall we do? Once again, in order to know the number of demultiplexer, guys, at sometimes my that is I'm murmuring, that is I'm talking about multiplexer, we are in demultiplexer, don't forget, right? So that is a demultiplexer, we are trying to identify the number of demultiplexer. So anyway, what we have to do, we should consider the gate that we are going to implement divided by the gate that we are going to use for that, that is the mux, right? So implementation is we are trying to implement 64. Which one we are using for that? We are using 2 power 1. So if I'll cancel it, let us see. 32 times of 2 will be 64, so we have to consider 32 by 2. Again 16 times of 2 will give you 32. Again 8 times of 2 will give you 16. Again 4 times of 2 will give you 8. Again 2 times of 2 will give you 4. That will also be divided by 2. Let's raise the question. See there, if I'll cancel it, we are going to get 32. Second case, we are going to get 16, and then we are going to get 8, and then we are going to get 4, and then we are going to get 2. At last we are going to get 1. Such that, see there, 32 plus 8 will become 40. 40 plus 20 will become 60, 63. So the total value should be equal to what? 63. Now what we have understood here, the thing is, listen, we are trying to implement this 64 multiplexer, that is 64, right? 64 in the sense which is equal to what we have to consider. Let me raise, that is 2 power 6. Am I correct? 2 power 6 in the sense what? That is equal to 64, right? Now I had given the general formula already, right? Whenever you are using any multiplexer by using 1 cross 2 multiplexer, I had given the generalized formula. This formula is only applicable for 1 cross 2 multiplexer. If you are using any other multiplexer by using 1 cross 2, then the general formula is what? In order to know the total number of demultiplexer that it should be required in order to implement any multiplexer by using 1 cross 2, demultiplexer. So for the formula is 2 power n minus 1. Now for an example, in order to implement 1 cross 64 multiplexer by using 1 cross 2, what I have to do? You will have to replace this n by 6 such that it will become 64. 64 minus 1 should be equal to what? 63. That is what we got here. So the answer should be correct, right? So you can easily identify whenever, right? So எந்த maximum use பண்ணி implement பண்ணிக்கலாம் with the help of 1 cross 2, but the general formula is what? 2 power n minus 1. But in rest of cases, if they are using some 1 cross 4 mux or 1 cross 8 mux, then you have to go with the general procedure in order to identify the total number of demultiplexer. Okay, fine. Things are clear to you all. Let us take one more example for this, right, in order to get the clear idea. Now the question is, we have to identify the number of 1 cross 4 demultiplexer that it should be required to implement 1 cross 64 demultiplexer, right? So let us raise the question against of 1 cross 4. When I am considering 1 cross 4 by using 1 cross 64, what will you do? Once again, the formula is what? Implemented mux divided by the mux that we are going to use for that, right? So that will give you the total number of demultiplexer, demux. Let's see the answer for this one. 64, again we have to divide it by 4. How many 64s are there? 16 times of 4 will give you 64, of course. Again 16 can be divided by 4. 4 times of 16 will give you 4. So 4 also can be divided by 4 once again. So the answer is what? 16 plus 4 plus 1 such that it is going to be what? 21. The answer is what? 21. See there, can you use the formula that we saw already, 2 power n minus 1 here? No, I am getting 21, but here we got 64. If you use that formula, then it will be affected you, right? So you won't get the exact answer, okay? So the correct answer is what? So 21. 1 cross 4 demultiplexer should be required to, it is required in order to implement 1 cross 64 demultiplexer. I hope things are very clear to you all. So this is all about demultiplexer. This is all about demultiplexer. Now next what we are going to do, let us see our next target. We have to design magnitude comparator, right? So keep the heading. Next we are going to design magnitude comparator, right? That's quite interesting actually. What is the purpose of magnitude comparator? That's also very simple application, right? Magnitude comparator அப்படினா மீனிங் என்ன? Which person, right? உங்களுக்கு வந்து யார் வேணும் அப்படிங்கறத சூஸ் பண்றதா magnitude comparator, right? For an example, நீங்க ஒரு ஹோட்டல்ல இருக்கீங்க. ஹோட்டலுக்கு யூசுவலா ஹோட்டலுக்குள்ள போனோம்னா என்ன பண்ணுவீங்க? We are looking for the menu, right? மெனு பார் போயிட்டு என்ன பண்ணுவீங்கன்னா you are selecting என்ன ஃபுட் வேணும் அப்படிங்கறத மெனு கார்டு பார்த்து நீங்க செலக்ட் பண்ணுவீங்க இல்லையா? என்ன ஃபுட்டுங்கிறத நீங்கள் செலக்ட் பண்ணணும். தட் இஸ் கால்ட் செலக்டர், ரைட்? ஸோ அப்போ நீங்கள் என்ன பண்ணுவீங்க? there are hundred varieties are there, right? அப்போ நீங்கள் என்ன பண்ணுவீங்க? அதுலேருந்து you are specifically selecting, right? உங்களுக்கு என்ன வேணும் அப்படிங்கிறத நீங்கள் தான் சூஸ் பண்ணணும். that's called comparator. Simply we are calling them, that is called comparator. What is the purpose of comparator? It will compare, right? உங்களுக்கு ஒரு டேட்டா இந்த இப்போ ஃபார் an example, இப்போ நம்ம இதெல்லாம் ஸ்பேஸ்லலாம் பார்த்தீங்க அப்படின்னா there are some movies you can watch that one, gravity, right? ஸோ இப்போ அந்த மாதிரி மூவிஸ்லாம் பார்த்தீங்க அப்படின்னா ஸ்பேஸில் வந்து ஃபுட்டை வந்து எப்படி எடுத்துக்கிறது, you can see that one, right? அங்கே வந்து there will be some automatic machines will be there. You have to just enter some codings like pizza வேணுமா இல்லை பர்கர் வேணுமா, அந்த மாதிரி வந்து நீங்கள் என்டர் பண்ணீங்க அப்படின்னா ஆட்டோமேட்டிக்லி that will அது வந்து உள்ளே வந்து செலக்ட் பண்ணி அதுக்கு தேவையான ஈக்குவலன்ட் கோடிங் will be given to that, right? ஸோ அந்த கோடிங் ஏற்ற மாதிரி நீங்கள் வெளியில் பீஸான்னு டைப் பண்ணுறீங்களா, உள்ளே வந்து அது கோடிங் டிஜிட்டலில் வந்து பைனரியாக வந்து கோடிங்ஸாக அது கன்வெர்ட் ஆகிட்டு அந்த ஃபுட்டை வந்து அது நீங்கள் கரெக்டாக டைப் பண்ணதுக்கான corresponding code will be generated. That code will bring, right? So கொஞ்ச நேரத்துக்கு அப்புறம் என்ன ஆகும்னா வெளியில வந்து செப்பரேட் அந்த டோர் ஓபன் ஆகும். லைக் ஏடிஎம் கார்டுல நம்ம மணி எடுக்கிறோம் இல்லையா, தி சேம் வே food will be delivered, right? So that is called automatic machine. So coming back to the conclusion, what is the purpose of the comparator? So comparator work என்ன அப்படின்னா, நீங்க டைப் பண்ற இன்புட்டை உள்ள இருக்க ஃபுட் கூட கம்பேர் பண்ணணும். லைக் ஐ எம் டைப்பிங் pizza. இப்போ பீஸா டைப் பண்ணுறீங்க அப்படின்னா பீஸாவுக்கு கரஸ்பாண்டன்ட், ரைட்? ஸோ பீஸாவுக்கு கரஸ்பாண்டன்ட் கோடிங்கை வந்து கம்பேர் பண்ணி ஜஸ்ட் இட் ஹேஸ் டு அதை வந்து கரெக்டாக டெலிவரி பண்ணணும். தட் இஸ் தி ஒர்க், ரைட்? தட்ஸ் ஆல், இட்ஸ் ஓவர். ஸோ சிம்பிளி வி நோ தி மீனிங் ஆஃப் கம்பேரட்டர். லெட்ஸ் சி how to compare the datas in digital. Anyway, the happiest news in digital is there are no big things to compare. I have only two persons, either it might be 0 or it might be 1, right? So we can go up with the two zeros, or you can go up with the two ones, or you can go up with the 0 1, or you can go up with the 1 0, right? So that is the happy things, right? That is happiest thing when we are going up with the digital system, right? So let's come back. Let's discuss about digital electronics, right? So let us take the comparator, right? That is called magnitude comparator. Let's see how your comparator will compare the things, right? And I will also teach you how to solve the problems in your examination point of view, right? That's quite interesting actually. Let's see. Now the thing is, for an example, let us select the hotel, some specific hotel. Let's take some food, like some pasta will be there, some pizza, we'll take some chicken rice, we'll take some vegetable rice also, right? So now the thing is, we have to select, right? I just want some pizza, and we'll take three foods, right? Chicken rice, next we'll take vegetable rice, and we'll take pizza, right? So now with that we are going to do some comparisons, right? So let's see. Let's select the magnitude comparator. Now we are going to discuss about magnitude comparator. It's quite interesting actually. Yeah, let us see. Magnitude comparator. What it will going to do? Very simple, right? For an example, let me select only 2 bits, right? I'm selecting only 2 bits, A and B, right? Now the thing is, there will be some certain code will be given to you. If you have AB, then there are 4 possibilities, 0 0, either it might be 0 1, or it might be 1 0, or it might be 1 1. Right? Okay, fine. So let us see for this AB, right? So for these 4 combinations, how many possible outputs are there? Now there are 3 possible outputs. Let us see one by one, right? So you may expect 3 possible outputs. The possible outputs are, for an example, first when A going to be greater than B, then one type of food will be selected. When B is going to be greater than A, then some another type of food will be selected. Whenever B is going to be equal to A, some other type of food will be selected. I said we are going to consider chicken rice, and then we are going to consider vegetable rice, and then we are going to consider some pasta, or just I said pizza, right? So just to consider pizza. Let's see what happen now. Now when it is going to be 0 0, when A and B are going to be 0 0, automatically what will happen? See there, the value of A is 0 as well as B also 0. Are they equal or not? Yes, they are equal. If they are equal, automatically third person will be selected. For example, pizza will be selected and it will be delivered to you all, right? So second case, suppose if you are selecting 0 1, if I am selecting 0 1 select panning அப்படினா A is 0, B is 1, automatically 0 is less than 1, such that B is, that is A is less than B, right? Or I can say B greater than A, B greater than A. If B greater than A, then correspondent, right? So this line will be selected. Here we put what? Vegetable rice. So automatically vegetable rice will be selected, that is delivered to you all. Suppose if you are selecting 1 0 selecting, automatically what will happen? Chicken rice, right? So you are going to receive chicken rice. Which is chicken rice? A is, okay, fine. So let us select the third case. Now what automatically when you are putting 1 0, which one will be selected? Chicken rice will be selected, right? So next thing is what? 1:1. 1:1 in the sense what will happen? Once again both are going to be equal, automatically last person will be selected. So this is called what? Equality bit. They are called equality bit, right? So let's see what happened. So remaining table, whenever you are going to get 0 0, whenever you are entering 0 0, automatically pizza will be selected, rest of 2 persons will be disabled. Second, whenever you are entering 0 1, automatically vegetable rice will be selected, rest of people are going to be disabled. Whenever you are selecting 1 0, automatically what I can say, chicken rice will be selected, rest of people are going to be 0. Whenever you are selecting 1 1, once again pizza will be selected, rest of guys are going to be 0. Clear? So that is called comparator. Simply understand, that is called comparator. There are no big things to understand. Let's close. Right? Now let's write the expression for A greater than B. Whenever A is going to be greater than B, its correspondent logic is, right? இப்போ அவுட்புட்ல எனக்கு என்ன செலக்ட் ஆகணும்? A greater than B means I am just expecting chicken rice, right? So இப்போ chicken rice க்கு output என்ன வரும்? You are going to receive chicken rice whenever the logic, right? Logic என்ன வரணும் அப்படின்னா A dot B bar. Usually we are writing the expressions in SOP form only, that is min term. In min term, see, A greater than B means its correspondent min term. Here I am having 1, its correspondent input variables are A dot B bar. Do you all agree with me? In min term, 0 is not allowed, right? So we should take complement for this 0 such that A greater than B, its correspondent condition is A dot B bar. That is the condition to select what? Chicken rice. Now when we are going up with the second case, if you want to select, right, some of you might be purely veg, right? if you are purely veg, automatically you will select what? Vegetable rice. If you are going up with the veg, then what will happen? Its correspondent coding, right, that you have to enter is a bar dot b. That is called what? Purely veg rice. Now let's looking for pizza, right? So after a long time, I wish to take pizza, right? Yeah, let's see what happen. If you want to, right, you are going to receive pizza whenever your inputs are going to be equal. There are two options in order to receive the pizza. Either it might be 0 0 or it might be 1 1. Let's see 0 0 in the sense, since we are writing the function in min term form, so automatically min term in the sense zeros are not acceptable. We should take complement for that, right? So plus and 1 1, it is acceptable. Its correspondent. See there we have min term at two places here. So its correspondent inputs are going to be a into b. Did you notice one thing? Right, see there a bar b bar dot, that is a bar dot b bar plus a dot b is equal to what? A XNOR of b. Do you all agree with me? That is XNOR gate. So what is the conclusion? To receive the pizza, we have a simple logic that is called XNOR logic, right? So whenever you are looking for the hotel, right? So whenever, right, you are visiting the hotel, if you want pizza, then you can use XNOR logic in order to receive the pizza. For another two cases, in order to receive veg rice or chicken rice, we should go with the specific selections, right? So totally we have three possible combinations. Either it might be a greater than b, or it might be less than b, or it might be equal, right? So whenever we are going to get, that is called parity check, that is equality checker in the sense, if your inputs are going to be equal, automatically XNOR logic will be selected, right? So whenever we are having equal inputs, its correspondent logic is called XNOR logic, right? So don't forget, that's very important. So we are just traveling along with the XNOR logic. So in the same way, we can raise, that is we can compare more number of bits, like you can compare 2 bits with the 2 more bits, like I can select A0 A1 here, we can select B0 B1 here, and you can see all possible combinations, right? Like 0 0 0 1 1 0 1 1, you can see all possible combinations, and you can see the correspondent outputs, right? For the correspondent output, and you can just travel along with this, right? I hope things are very clear to you all. That is how we are doing, that is solving the problems in magnitude comparator. Let's see. I told you now, in your examinations at all, you will be tested with some other type of logical questions. Let us see. Even in IES also, you can see there are numerous questions in this logic. Let's see. Let me do one thing. Okay, let me rub this one and let me write the answer. Then you'll get the clear idea. The question is total number of possible comparisons, right? So total number of possible comparisons in magnitude comparator. So first of all, right, so based on the number of bits, right, for n bit, if I'm having n bits, suppose if I'm having n bits, then total number of possible comparison, the total number of possible comparison, right? So the total number of possible comparison. So let us write this one. The total number of possible comparison is 2 power 2n. Clear? Total number of possible comparison. Now here the case number 1, right? If A is going to be equal to the value of B, A is equal to B in the sense, you can see its correspondent possible outputs, its correspondent possible output combinations. Let me call them as Y1 simply, or you can consider Y0. Its possible output combination should be is equal to 2 power n. Now suppose the second case, suppose if A is not equal to B, A is not equal to B in the sense, there are two cases. I know, we all know two cases in the sense, either A might be greater than B or it might be less than B, but it is not equal to B. In that case, the total number of possible combinations are, see there, this is the total number of possible. Out of this total possibility, 2 power n combinations will give you A is equal to B, right? Rest of things, if you want to know the rest, we should subtract from total value, we have to subtract 2 power n. Do you all agree with me? Now from this, we have to take average in order to obtain the possible combinations for A greater than B is, let me call this one as Y1, such that is going to be 2 power 2n minus 2 power n upon 2. Similarly, write the combination when A is going to be less than B, its correspondent Y2 is going to be 2 power 2n minus 2 power n upon 2. Just average, because both are always equal. Both are always equal, right? So now let's check how many bits that we had compared now. இப்போ நம்ம எத்தனை பிட்ஸை கம்பேர் பண்ணோம்? I took only one bit. A is single bit, B also is single bit. Just we made a comparison between single bits, right? One bit comparison. That is called one bit comparison. For one bit comparison, so let us see. For one bit comparison, when we are comparing only single bit. A single bit means A is the single bit, B is also a single bit. I'm just making the comparison between these two single bits, 0 0 0 1 1 0 1 1, that is one bit comparison. So in one bit comparison, n is going to be 1, such that the total number of possible combinations for one bit comparison is 2 power 2, because n is going to be 1 now, so 1 into 2 will become 2, 2 power 2 will give you 4. Total number of possible combinations are going to be 4. Now in this case, the equivalent value, that is y naught, means when A are going to be equal, how many possible combinations we are going to get equal, that is equal bits, like A and B are going to be equal to each other. In order to know that one, we should raise, that is the formula is 2 power n. But since the value of n equal to 1 only now, 1 bit comparison, so it is going to be what, 2. How many bits we got? See there, sorry, how many terms we got? 1 and 2. Exactly, that is what I am telling. So the third case is we should raise y1. Y1 is going to be what? 2 power 2n, that is going to be what? 4 minus 2 power n, that is going to be 2 upon 2, such that this is going to be what? 4 minus 2 is going to be 2. 2 by 2 will give you 1. See there, we got only one term, that is A greater than B. I took this one. We got only one term. Am I correct? Yes. Similarly, we are going to get y2. How many terms we are going to get? 2 power 2n minus same formula, we are going to get 1. So totally the total possible combinations are 4, of course. See there, 1 2 3 4, that is correct. And 2 power n, that is a number of combinations. There A are going to be equal to B. We got 2 combinations, that is also correct. Yes, we got 2. Rest of people are going to be 1 1. So everything is perfect now. So like that, anyway, for your understanding, I just proved this one, but don't forget this generalized relation, because there are numerous questions. Till now there was no questions in TRB also, but this time you can expect, because chilly question, right? You are supposed to consider that, keep this relation with you. That's more than enough in order to crack the question simply. Clear? Yes, I hope things are clear to you all. Class is going good? Any issues? No, I think board is also clear now. Let's continue our journey. So that is how we are traveling along with the comparator. I hope things are very clear to you all, right? See, in the same way we can also design with some logics, right? Big comparators also we can design here, but I don't want to waste our time. So let's see. So this is the general, and that is how we are doing comparison. That's more than enough, right? That is more than enough. Let us discuss about the next person, that is called coding, right? So we are going to do coding now. That is, there are two type of coding we are going to look at now. That is called encoder and decoder, right? Of course, where we are encoding the data and where we are going to decode the data. Very simple, right? First of all, I'm just raising the question against of you all. Tell me, what do you mean by encoding and what do you mean by decoding? அதில் உங்களுக்கு என்ன புரியுதோ, என்கோடிங் டீகோடிங்னா உங்களுக்கு என்ன புரியுது? We are going to encode some selected, that is some specific data, right? We are going to encode some specific data. இப்போ என்கோடரோட அட்வான்டேஜ் என்ன அப்படின்னா, ஃபர்ஸ்ட் திங், ஒரு நிறைய இன்ஃபர்மேஷன் இன்புட்டில் இருக்குங்க. ஃபார் எக்ஸாம்பிள், இப்போ இங்கேருந்து நான் வந்து என்ன பேசுகிறேன்னா, சைடில் வந்து ஒரு ஃபேன் ரன் ஆகிட்டு இருக்கா. ஜஸ்ட் அசியூம் லைக் திஸ், தட் ஃபேன் இஸ் கிரியேட்டிங் சம் நாய்ஸ், right? And our house is, right, being placed, that is our classroom is being that is placed nearer to the what I can say road, right? Such that there are many vehicles will always traveling nearer to our house, right? So what will happen? So you can hear some noises, right? In this classroom you can always hear some noises. So what will happen? That noises will become a signal for you all, because you guys are just listening here. So what will happen? Whichever the you are going to listen, my voice as well as fan noise, as well as what I can say, that vehicle noise, all these things are, you are going to hear all these things. With this you are also keeping your, that is you are watching, at the same time you are listening, your concentration, many things are there. But the thing is, encoding means what? இப்போ நம்ம இங்க நிறைய டேட்டாஸ் வந்து செலக்ட் பண்ணிருக்கோம், right? So there are many input lines, like noise are all going to be the input now, as well as my voice also going to be the input, right? So there are many input lines. Now out of these many input lines, we are going to encrypt the data into a single, that is we are going to increase the நிறைய input lines இருக்கு. அவ்வளோ லைன்ஸ் வந்து அப்படியே கொண்டு போறது போல நம்ம என்ன பண்ண போறோம்னா, we are going to encode the total data, and that is அதை நம்ம என்ன பண்ண போறோம்னா, மொத்தமா பிடிச்ச ஒரு பாக்ஸ் குள்ள போட்டு we are going to use very simple, that is small number of lines, right? Very less number of lines in order to transmit the data with avoiding noises இல்லாம, right? So in order to transmit the data without noises. right? So that is simply called encrypt, that is encoding. Receiving end line automatically that code will be again decoded, and then we are passing it to the demultiplexer. So first thing is multiplexer will going to take the responsibility in order to send the signal in the sending end, whereas that signal will be passed to the encoder. Now encoder will compress the data and it will select very less number of output lines, such that through that output line we are going to transmit the data. Now automatically at the receiving end, decoder will receive the signal and it will encode, that is again it will decode the original data, and then that original data will be passed to the multiplexer. Now multiplexer will receive that signal and once again that will distribute. Okay, so that is the complete application of your, that is communication channel. Let's see what happened. So we are going to discuss about encoding and decoding of your signals, right? So let's go ahead with shall we select encoder? So let me do one thing. First we will take a decoder and then we will discuss about encoder. Okay, that's good, right? Okay, we can go with any possible combinations, because just now I had completed demultiplexer, so going up with a decoder might be comfortable for us. So let's go ahead with the decoder. So let us select. So first we are going to discuss about decoder. So we are going to discuss about decoder now. Let us see. Now what do you mean by decoder? Of course it is same as your demultiplexer. See what we saw in demultiplexer, we have 1:2 power n, that is 1 cross 2 power n is our demultiplexer. Similarly n cross 2 power n is our decoder. N cross 2 power n is going to be our decoder. So the general structure is we are going to consider n cross 2 power n, right? So that is n input line, 2 power n output line. With this we are going to consider one more pin, that is called enable pin. That is called enable pin. Of course we should talk about the enable pin later, right? There are two type of enable pins. We'll see soon. After completing encoder and decoder, I will talk about this person also in order to get the clarification, right? Fine. Let's start our discussion with the encoder. So in the input line, that is from the input side, we are going to consider n input lines, whereas in the output side we are going to consider 2 power n output lines. So let me rub these things. Now let's start our journey. In this decoder, case number 1, when we are raising, that is when we are putting n equal to 1, if I am just simply keeping n equal to 1, automatically in this decoder what will happen, what we are going to get? So let us see. In decoder, when I am putting n equal to 1, so we are going to get what? 1:2. 1:2 means how many input lines we are going to consider? Simply one data line with this enable pin. Enable pin we will see what we are going to do with the enable pin. And in the output side we need 2 data lines, no? Yes, we are going to consider 2 data lines, right? So let me consider y0 and let me consider y1. For an example, let us consider this is the input line i0. Now what we are going to do, or simply take I, that's better, much better, that is I. So let us make the truth table for this 1 cross 2 decoder truth table, right? So let us see how we are going to receive the input, right? So sorry, output. Now the input line is we are giving I as the input, right? Such that in the output side there are 2 possibilities, right? Output line is either you can receive y0 or you can receive y1, right? You can receive y1. So enable pin, for an example, enable is set. We set enable pin, right? So okay, let me demonstrate this one also. Let me consider enable pin with this here itself, right? If enable is 0, right, for an example, still now we did not give any input signal also. We have not given any input signal also. So what will happen automatically, right? See, till now I had not given any input signal, right? So enable எதுமே நீங்க கொடுக்கல அப்படினா automatically your output is going to be deselected. We are not going to receive any that is we are not going to receive any output signal, right? So the thing is, the second possibility is what? See, we are going to provide input signal here, right? So let us consider the input signal here. Automatically based on the input combination that we are selecting here, your output port will be going to be selected now, right? So for an example, let me enable the input line. Sorry, enable is going to be 1 now. Enable 1 in the sense your circuit will be activated, right? If your circuit on the activate agala abdina, output values are not known. That will be represented by the don't care, right? Because the information is cannot be collected. We are not collecting any information, right? And the time la output la enna mariyana or information ungalku irukum அப்படிங்கிறது you cannot guess it. Just அப்படி இருந்தாலும் அதை கன்சிடர் பண்ண தேவையில்லை, because till now I did not activate my circuit, right? Because we are in combination circuit பொறுத்த வரைக்கும் மெமரி கிடையாது அப்படின்னா அவுட்புட்டை பத்தி நம்ம வரி பண்ண தேவையில்லை. ஐ மீன் பாஸ்ட்டை பத்தின வரிஸ் நமக்கு தேவையில்லை, ப்ரெசென்ட்டை மட்டும் தான் we are going to travel, right? So the conclusion is what? So if your input pin, right? So let us discuss about the input pin. Now if your input pin is going to be 0, automatically y0 will be enabled. Such that y1 is going to be 0. Now when your input pin is going to be 1, automatically y1 will be enabled, right, and y0 is going to be 0. That is the truth table for your 1:2, that is a decoder. Clear? So let us see how to implement this circuit, right? So in order to implement this circuit, see there I am in need of one enable pin, and we should set enable value as 1 in order to receive the output, and then we should talk about the input, also. Let's raise. Now what is the value of y0 here? Y0 is equal to, we are receiving only one what I can say output line, so min term is 1 when we are receiving I bar. We should just take complement for the input line, right? So we are going to receive, okay, if you want to consider enable pin with this, you can consider. I'm just multiplying it by enable, because since we are writing the expression in min term, right? So we'll have to first we have to perform AND operation, and the zeros are not acceptable. That's all. There are no more things to discuss. Now is similarly y1 is going to be, we are receiving 1 here, its correspondent input is I only. With this we are considering what? Enable pin. Let's see what happened. How to develop this circuit? See, first case y0. In order to receive the y0, I am in need of I0 bar. So let us consider one inverter here. With this I am in need of E, such that they are going to be multiplied together. So multiplier in the sense we need AND gate. So that is how we are receiving the output. Second case, right? So second case is going to be, right, so we need a enable pin as well as we need of I, and let me join together in order to receive the second person, that is called y1. Clear? So that is going to be your implementation of 1:2 decoder. I hope things are clear to all. Let us raise. Let us design. Class is going good. Wait a minute. Let us come back. Oh, sorry. Yeah, I think class is going good. Sorry for the interruption, because I'm always having some fear regarding class. That's why I'm checking often. Fine. Let's raise the input. Let us consider two input lines, that is n equal to 2. Let me consider n equal to 2. Let us see how to design the decoder circuit, right? So for two input lines. Now let me rub these things. Let us design n equal to 2. Please consider n equal to 2. You please design by yourself, right? Because I said digital in digital. Only thing is, once you understand, you can play with this circuit, right? You don't need to memorize anything. So n equal to 2 in the sense, okay, let me raise. What you have to consider? One enable line. Of course, see, let me draw the general circuit first. N equal to 2 in the sense, how many input lines should be required? Let us see. When n equal to 2, I have to consider 2 input line, because 2:4. With this, we are going to consider enable pin, right? So let us raise. Input lines in the sense, I am in need of I0 and I1. 2 input lines should be required, whereas in the output side, we are going to consider 4 lines, such that output lines are going to be I0, we are going to consider I1, we are going to consider I2 also, we are also going to consider, consider Y0, Y1, Y2, Y3, that will be much better. Fine. So let's go ahead with this. Shall we design, that is, shall we draw the truth table for this? First, let me write the output. Y0. When Y0 will be enabled, see there, let us consider, if your enable pin is 0, then your circuit won't be activated, such that all these values are going to be what? Don't care. X, 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 X. When enable pin is going to be 1, automatically for 0, 0, Y0 will be enabled. For 0, 0, Y0 will be enabled. Automatically, its output will become enable pin A, I0 bar. Since we are writing in min term form, so in min term form, zeros are not acceptable, right? So when input are going to be 0, 1 combo, automatically second pin will be enabled, such that your output is going to be that is 0, 0, 0, 1. 0, 1 in the sense, 0 we should take complement. For 1 we no need to take, because 0 only not allowed. Y2 in the sense 0, 0, 0, 1, 1, 0, right? So 1, 0, 1, 0, 1, 0. 0 is not acceptable, we should take complement. Last person is going to be enable pin is acceptable, such that I0 and I1 both are acceptable. Clear? So now we can also write what I can say truth table if you want. So let me write the truth table here. So let us write truth table, right? In truth table, what we are going to get? So first of all, in truth table we have to consider enable pin. Yes, that is going to be enable pin, and then we have to consider 2 input lines, and then we have to consider 4 output lines, 1, 2, 3, right? So totally we have to consider 4 output lines. Let me close this junction here. So that is enable pin, and the input line are going to be I0, I1, output lines are going to be Y0, Y1, Y2, Y3. Clear? So let us see what will happen. See there, guys, just assume output la nama enna consider pandrodina active high output, right? So the output that I am always considering here is called active high output. That is called active high output. Later you will understand what I am trying to conclude regarding this sentence statement, right? So I'm considering active high end output, right? So let us see, if enable pin is 0, then we no need to much bother about the input, right? And we no need to worry about the outputs, because since my system is not enabled. Now when enable pin is going to be 1, automatically what will happen, you can start with your combo 0 0, you can take 0 1, you can consider 1 0 1 1. There are 4 possibilities with the enabled pin. Circuit is being activated when 0 0 when we are passing 0 0 through the decoder, automatically y0 will be enabled. Anyway, rest of all people are going to be 0. Now when we are considering 0 1 possibility, in 0 1 y1 will be enabled, rest of all are going to be 0. When we are considering 1 0, automatically this one, right, that is will be 0, this one will be 0, this person will be activated, this one also going to be disabled. When all these guys are right going, sorry, when both of guys are going to be 1 1, automatically y3 will be enabled, rest of guys are going to be 0. That is the truth table for the 2x4 decoder, right? So let's see how to implement the circuit, right? So in order to implement the circuit, how many lines are required? Let us consider enable pin, right? And let us consider I0. Let us consider I0 also, right? I said if you want to consider complement, right, with this directly you can consider. That is the actual way of your circuit implementation. Let me consider one more combination, data selector. So that is I1 input line, so that is, let me call it as I1. Let us receive the output, right? So the output that we are going to receive, case number 1, we need E into I0 bar I1 bar, right? So that is E, this is going to be E, let us see this one, this is going to be E, I0 bar, so this is I0 bar. We should take the line from inverter, right, such that output is going to be what? This is your output Y0. See what I am doing here, sorry, yeah, that is going to be your Y0. Let us see the second one, E into I0 bar I1, right? So let us see, that is going to be E now, this is going to be E, and I0 bar means we should take the line from here, I1 means we have to take the line from here, such that all are going to be joined together strictly with the AND gate. Let's see third one, E I0 I1, right? So E, this is going to be this is going to be E, and then I means we should take, without complement we have to consider I1 bar, so we should take let me join them together such that this is going to be Y2. Now finally we are going to consider what? All are going to be 1, such that let us see enable pin, this is going to be enable pin, and this is going to be 1, and this is also going to be 1, such that what will happen, you are going to get Y3. I hope things are very clear to you all. That is how we are doing the implementation for the 2x4 decoder, right? So in the same way we can also raise, right? We can consider n equal to 3. If I will consider n equal to 3 input lines are going to be, here we are going to consider 3 input lines, and the corresponding output lines are going to be 8, and you can just follow the same procedure, right? So I am just restricting with this. Let's see implementation of any circuit by using lower order circuits, right? That is lower order decoders. That is the next question. Let's see how to do that one. So let me rub this one. That is how we are decoding the data and how we are implementing it into the correspondent circuit. I hope things are clear. See, don't consider NAND gate. If I'll put any bubble, please rub that one. AND gate, but at sometimes I'm putting NAND gate. That is wrong, right? Don't consider bubble if I'll consider. Fine. So what is our next task? Let us see implementation of any decoder by using what? Lower order decoders, right? So let us see, for an example, let me consider anyway the general order is n is to 2 power n, correct? This is the general order. Now with this general order, what we are going to do, let's perform. The next thing is, now we should raise, for an example, if I will consider n equal to 1, right, then you will get 1 is to 2. Now the question is, identify the number of 1x2 decoder that it should be required in order to implement. Let me consider n equal to 4 here. N equal to 4 consider panninga, that is 4 cross 2 power 4, right? So 2 power 4 in the sense that is 16, right? So let us consider that is 4 is to 16 mux. Anyway, the procedure will be remain same. It is same as our demultiplexer and multiplexer that we saw already, which is your 2 power n combination. See there, that is n. This is also n, which is your 2 power n. This is 2 power n. This is 2 power n. Correct? Now let's rise in order to identify the number of decoders, right? In order to know the number of decoders, the formula is, right, the decoder that we are going to implement, right? So the decoder that we are going to implement divided by the decoders that we are going to use in order to implement. Let's see the answer for this one, right? The answer is what? Implementation in the sense 16 upon we are going to use 2 such that plus. If I'll cancel it, we are getting 8 now. Again 8 can be divided by 2, we are getting 4. Again 4 can be divided by 2, we are getting 2. Again 2 can be divided by 2. Such that how many people should be required? 8 plus 4 plus 2 plus 1, such that we are going to get what? 10, 15. So totally 15 1 cross 2 decoder should be required in order to implement 4 cross 16 decoder, right? So let us raise the question against, for an example, let me consider n equal to 2. If I will consider n equal to 2, then we are going to get 2 cross 4, right? Now let us raise n equal to 5 in consider, it is going to be 5 cross 2 power 5 means that is going to be 32. Now the question is, identify the number of 2 cross 4 decoders should be required in order to implement the 5 cross 32 decoder, right? So once again, in order to know the number of decoders, let us see the total number of decoders, right? That is 2 cross 4 decoders should be, how will you find the decoder that we are going to implement? For that, the decoder that we are going to use, right? Let's see the answer for this one also. The answer is, implementation is we are going to implement 32, right? Upon use, we are going to use 4. Can you cancel it? Yes. 8 times of 4 will give you what? 32. Such that 8 can also be divided by 4. Yes. 2, right? So but you cannot, 2 cannot be divided by 4 further, right? So we can just stop with this. So what is the answer here? If I will cancel it, we are going to get what? 8 combination plus if I will cancel it, that is going to be what? 4 cross 2, that is we are going to get 2, such that we are going to get what? 10 what is 2 cross 4 decoder should be required in order to implement 5 cross 32, right? 5 cross 32. Okay, I hope things are very clear to all. Just to remember the procedure, that is sufficient. Okay, that is more than enough in order to implement the number of decoders, right? Yes. Let me rub this one. So next, what we are going to do in the same way, once again I had collected few questions. I don't know where I had been stored that one, right? Let me try to solve those things if it is possible. Please wait a minute, let me find, because I don't know where I stored that question. That's I found some very good questions actually. Yeah, please be patient. Let me check it by myself. Now next we should talk about, anyway the next thing is we should discuss about decoder only, right? So there is encoder, right? So because decoder is over, immediately we should talk about encoder only, right? I hope we all know how to design the encoder circuit, right? Okay, I don't know where is the things. First we will design encoder. Yeah, I left that question somewhere. Okay, fine. Okay, we'll see at last. Okay, next we have to design, right? So encoder. See, first of all we have to understand these things, right? See, what is the difference between decoder and encoder? Decoder and encoder in the sense, first of all, in decoder we are again deselecting the data, right? So the complete structure is, first of all, guys listen, the complete structure is, I told you, from the sending end we are going to select the data with the help of encoder. For an example, here I am using n equal to 3 encoder, right? Encoder in the sense we have to raise, right? See, in deselector, that is what I can say, in decoder we are going up with the what? N cross 2 power n, whereas in encoder we should raise what? 2 power n is to n, that is encoder. If I will consider n equal to 3, automatically what will happen? 2 power 3 is to 3, such that in the input side we are going to consider 8 lines. We are going to consider 8 lines. Right? So let us raise the question let us draw this one, 3, 4, 5, 6, 7, 8. Totally we are considering 8 lines, but in the output side it's required. See, only 3 lines should be required in order to transmit the data. I said from the input side, right? So we are going to encrypt the data and then we are transmitting it to the receiving end, right? So in the receiving end, what will happen? Again we are going to consider 3 cross 8 decoder, just opposite to the encoder, right? So such that the decoder once again will deselect the data. Let me consider 3, 4, 5, 6, 7, 8, and it will pass the data to the output side. See there, this is the sending end. So we are in sending end, and this is going to be the receiving end. We are in the receiving end. Now in between the sending end and the receiving end, see there, how many lines are there? We are using only 3 lines. But see there, whereas in the input side we are considering 8 lines. So that is the beauty of your encoder and decoder. We no need to consider this many lines in order to transmit the data. Your data will be encrypted into a small box and then it will be transmitted with a very less number of lines, right? So that is the advantage for it, and we are transmitting the data with the security without any issues, right? So that's the beauty of this one, and without any noises and interruptions, right? So collaborations without having any interruptions, right? Interference. We are simply transmitting the data from sending into receiving, and that is the purpose of your encoder and decoder. Simply we will see the application is what our mobile, our laptop, the TV, that is a television that we are watching in our home, all are what we are receiving, that is televisions and all we are receiving from satellite, right? And mobile is working with the towers, right? So we can see some tower post will be there near our homes, right? That post is transmitting the data, right? So from one point to another point. So anyway, at whichever the system that we are using in digital in our home, that in all systems we are using what? Multiplexer will be there, demultiplexer will be there, what I can say, encoder will be there, decoder will be there. They are playing with our circuit beautifully, right? So that's all. Just that much of things is sufficient. Just remember that one. Anyway, in order to proceed further, so let me conclude few more things about decoder. So first, let us complete. Now in decoder, I said we should talk about enable pin, right? So first, let us discuss about enable pin, right? And then we will consider encoder. That will be much better, right? From my point of view. Let's see in encoder. See, first of all, what do we mean by enable pin, right? So there are two type of enable pin. One is active low and another one is active high, right? So one type of pin is called active low pin and another type of pin is called active high pin, right? So active high pin. So we are going to consider two type of pins here. See, what do you mean by active low pin and what do you mean by active high pin? First of all, we have to discuss about these two person, right? And it's quite interesting too. See, listen, so for an example, I have a certain decoder here, right? I have a certain decoder, right? And I told you this is the point where we are going to consider our enable pin, right? So and for an example, let me take 1x2 decoder. N is 1, right? Such that in the output line we are going to receive, that is, this is our input data and this is the point where we are going to receive our output. Anyway, see there, first of all, this output is called what? Active high output. Your outputs are called what? Active high output. Active high output. There are two cases. One is active high output and another one case is active low output, right? So we are going to consider two possibilities now. Anyway, I am considering first output is active high output and your enable pin is, see there, in this enable pin, it is going to be active high in the sense directly I am giving one and I am just activating or triggering the circuit. That is called active high pin. Now what do you mean by active low pin? Active low pin in the sense we have to consider the same circuit. Let me consider active low pin. Now, when you are looking for active low pin, once again for your best understanding, let me consider 1x2 decoder. Now here in this output also, once again your output, I am treating your output as active high output only. There is no changes. I am just considering output is what? Active high output. I know still you are not getting the clear idea. So please be watch clearly, right? So the input side, once again I am going to get the same input information only. But I said what? This is called what? Active high enable pin. Active low enable pin in the sense here you can find a bubble. It means, let us consider, guys, it's very simple. It's very simple. The thing is, we have to, our target is we have to activate the circuit. System on the activate whenever you are passing the signal, right? In digital, from since when I was starting the digital itself, I told you in digital 0 denotes the ground potential and 1 denotes the electrical signal, right? So in order to activate the circuit, we have to pass some electrical signal. Just with the common sense, you should think. See there, here, if I will pass any signal, electrical signal, 1 denotes we are directly passing the electric signal such that your circuit will be enabled, right? We are using some backside, we are using some gates, right? That gates will be triggered, right? So that gate will be triggered with the help of this electric signal. Now coming back, so similarly if you want to transmit, here they are using one inverter. In digital, if I use inverter in order to pass the electric signal inside the circuit kulla electrical signal entragnum abdina, from outside we should consider 0, because then only that 0 is going to be inverted, right? That 0 is going to be inverted by the digital gate and then automatically 0 will become 1 and we are passing 1 means electrical signal is passed through the circuit such that your circuit is going to be enabled. Getting me? So that is called what? Active low and active high enable pin. So the difference between these two guys is whenever we have the enable pin with a bubble, right? So we should pass 0. That is what I would like to conclude, because if you will pass 0, then only your circuit will be enabled, right? If you pass 1 here, if you pass 1, then this bubble, it indicates there is one inverter. That inverter will take the that is, it will invert the input signal, right? It means if I will pass 1, invert of 1 is what? 0, right? 0 is not an electrical signal, so your system won't be enabled. So if you want to enable the system, you will have to pass 0 such that 0 will be inverted, it will become 1, so it will become an electrical signal. That electrical signal will going to activate the circuit, right? So I hope things are very clear to you all, right? So there are two types we are going to consider. One is called what? Active low enable pin, another one is active high enable pin, right? So anyway, active means your system will be enabled with which type of pin that we are going to use. Either you are going to use low pin or high pin, right? That will be decided by the bubbles or the lines that we are using here. I hope things are very clear to you all. Now, till now I did not talk about active high output. What do I mean by active high output? Once again, output is going to be active, right? I means what? 1. So it means in the output side you can observe, right, at sometimes even in your examinations also, without any bubble some circuit will be given to you like this, right? Whereas these type of outputs are called what? Active high output. Active high output, please notice these things, right? But at sometimes even let us see, this is active high output, right? So now let us discuss about active low output. Let me rub this one. Let me discuss about active low output. So our next target is we have to discuss about active low output. Yeah, what do I mean by active low output? See, active low output in the sense, one second. Yeah, so active low output na meaning let us consider the 1x2 decoder once again for the best understanding. Let us consider single input, right? And now this time I am considering active high enable pin. With enable pin, I don't have any issues, right? Anyway, there is no issues always with enable pin. Either you can go with active low enable pin or active high enable pin, right? It depends. But don't be confused with this enable pins. You have to understand, because there are numerous questions in the examinations, chilly questions. Just by looking at the question itself, you can keep your answer. That much of easy questions always you can find, right, in digital electronics. But the thing is, basics are very important. Now let's try and figure out the output. See, in the output side, you can see this type of output now. If I'll find this type of output, what is the difference between previous one and present one? See there, once again, there is a bubble. There is a bubble, right? So anyway, the thing is, in the output side, people are using two type of representation, right? So one is either you can find the bubble or you can see, let us see, since we are using active enable pin only, there is no whereas in the output side they are taking the line outputs directly like this, but they will put like this y0 bar and y1 bar. It is also means that what this is called active low output. Output is going to be active only, but low output in the sense with 0, right? We are passing 0, that 0 will be inverted and it will become an electrical signal. It will become an electrical signal, right? So such that what? That is called active low output, right? So this is also called what? Active. Output is active only, but for what? For low reference. Why we are passing low? Why? Because we have what? Inverted. If I pass 0, I will have to take what? I have to consider inverted version, such that your output is going to be active low. Clear? So this is called active low output and active high output. I hope now you all are getting the clear idea. Now the thing is, let us see how to implement this circuit, right? So because in your examinations, right, so at many times you are requested to implement this circuit with the help of what type of implementation? Let us see, some Boolean expressions will be given to you and you are requested to implement the circuit, right? Decoder circuit for the Boolean expressions that will be given, right? Let us see how to do these things, right? Let me discuss about active high output with a high active enable pin, right? So anyway, I no need to panic about the enable pin that I'm going to use, but my concentration with the output now. Let's see the target. That is, let us look at the answer for our question, right? So let us see how to implement any Boolean functions with the encoders, right? So let us consider. Let me consider some encoder here. Right now in this encoder, anyway, sorry guys. I'm really very sorry, we are in decoder, right? So we are in decoder. See there. Forgive me, I don't know why I am doing like this, right? I'm just blabbing, right? Sorry. So we are in decoder, fine, right? So in decoder, what? The lines that we are going to consider in general, that is n is to 2 power n with what? Enable pin. See, I no need to worry about the enable pin that I'm going to use. Either it might be active low enable pin or active high enable pin. I know how to activate now. And with this, we are going to consider n number of input signal. With this, here also I don't have any issues. We can continue up to n. And with this, in the output side, we are going to consider 2 power n combination. Of course, we are going to consider 2 power n combination. Now let us see how to design the circuit. Simply understand, right? The thing is, now I am just talking about active high output. Active high output, right? Now we should keep two things in your mind. Whenever we are discussing about active high output, what I have to do? Suppose if I am talking about active low output, then what I have to do? Active high output, active low output, active high output and active low output. Is that visible to you all? I don't know whether my system is working. Please, 1 second, let me check it by myself. I come out. I'm not watching the lecture now. Anyway, I hope things are going good. Yeah, that is visible only, right? Fine. See, now this board is big now, bigger than the previous one. Fine. I hope this is visible. Let me just make 2 columns here. Yeah, let's see what happened, right? So listen, you are requested to consider, right? In a box, I'm just putting the decoder, right? Into the box, I'm just putting the decoder. So here we are going to consider the decoder. Fine. Now in the output side, what I am going to consider? The thing is, in active output, right? Either you are requested to, right? You might be requested to implement min term or max term. There are 2 cases. Min term in the sense you will be requested to implement a sum of product form, right? And we also know at sometimes max term also will be given to you, and you are requested to implement the max term. Max term in the sense we should go up with the product of sum, right? So anyway, it does not matter at which gate we are, that is which thing that we are going to implement. The thing is, you will have to keep your attention with whether we are considering active output or active high output or active low output. That's very important, right? Suppose if you are going up with the active high output, in order to implement, let me consider, anyway we are going to consider n input here, right? In the output side, in order to implement min term, when we are going up with the active high output on the active high abdina, what bubble is not there, bubble, without bubble we are implementing the circuit. Appo enna agana min term, right? In order to implement the min term, right, you are requested to use OR gate. You are requested to use OR gate. Suppose if you want to implement a max term for the same decoder circuit with the active high output, right, that is the standard things, just we have to keep these things with you, right? You are requested to use what I can say NOR gate. You are requested to use NOR gate, right? Anyway, the combination is n is to 2 cross 1. Though I am not writing this one, by default you have to keep these things in your mind. Okay, so it is just going, we are going to consider n input, right? But the thing is what I am just requesting, one enable pin, right? There is no changes. But in order to implement the max term, we have to use NOR gate. In order to implement the min terms, we have to use OR gate, right? So let's raise the question against of active low output. Now when we are discussing about active low output, once again, in order to implement the min term, that is SOP, sum of product, what I have to do? Let's see what we need to do here. The thing is, once again we have to consider decoder. Once again we have to consider 2 separate decoders. Let's see how to do that one. Now the decoder circuit, right? In the decoder circuit, what I am going to do? Once again, you are requested to consider 2 power n. There is no changes, and you are requested to consider n inputs. Of course, we are requested to consider n input, and its correspondent output also going to be 2 power n. There is no changes. But think is what? Since we are looking for active low output, in active low output, when we are going up with the min term, you are requested to use NAND gate in order to complete the circuit. Just to use NAND gate, right? So next, if I am going up with the max term, then what shall we do? If we are going up with the max term, then we have to use, right? So once again, let's consider general is decoder circuit. Our circuit is what? Decoder only, right? And we have to raise, that is n is to 2 power n, such that we are going to consider n input lines, and we are going to consider 2 power n output lines, right? So 2 power n output lines, there is no changes, and the output is going to be what? AND gate. Output is going to be what? AND gate only. There is no changes. Clear? I hope things are very clear to you all. Please don't forget, this is very important, right? So let me show you some examples, right? In order to get the clear idea, let us take some examples. Let us implement them, right? Then you will get the clear idea, right? Now the thing is, some circuit will be given to you, right? Sorry, some function will be given to you, f of the boolean function, f of a comma b comma c, right? Which is will be equal to summation min terms they are considering. Let us consider 0 comma 1 comma 2 comma 3, right? So okay, let me consider some other variable 6. Okay, that should be fine for us. it clearly denotes how many variables that we are going to consider? 3 variables, right? And the min term. Now you are requested to implement the circuit with the help of what? Active I output, right? Active I output, it clearly denotes what? We are using min term. Min term with the active I output. So what is the answer? We have to use OR gate in order to find out the output, right? So for that, it's clearly denote what? I am in need of 3 input lines, right? Because output is going to be 8 lines now. Because ABC in the sense we should consider 3 input lines, right? So let us design the circuit now. So we are going to consider what? 3 input lines, A, B, C, right? So let us consider A, B, C, right? Its corresponding output lines are 1, 2, 3, 4, 5, 6, 7, 8, such that first one is going to be Y0, Y1, Y2, Y3, Y4, and Y5, Y6, Y7. Totally we are going to consider 8 lines. Right now let's see which lines are going to be. That is very simple circuit, right? How will you do that one? 0, 1, 2, 6. Which is 0? This is 0. Of course, where is 1? This is 1. Where is 6? And this is 6, right? So this is going to be our 6. And 0, 1, 2 also we are going to consider. No? Yeah, that is going to be 0. Simply, right, merge them with what? OR gate. That's all. It's over. That is going to be our net output. Any doubts now? There are no things to write. Doubts value, right? So similarly, if you are requested to consider max terms, if max terms implement panna solrana, see there, this is min term. What about its correspondent max term? Let us implement max terms. It's equivalent to max term, we all know. Max term is what? Missing terms, right? 0, 1 is there, 2 is there, 3 is not, 3 is missing, 4 is missing, 5 is missing, 7 also missing. Shall we implement them? Yes. See that this is max term. Anyway, you are requested to use what? Active I output only. Active I output means we know what to do. We have to use what? NOR gate, right? And let's see how to implement that circuit also, right? Is it visible to you all? I'm just, can I go? Yeah, we can go, right? We have space now, right? That's much better now, right? Yeah. So the input lines are once again going to be 3 lines. We are going to consider A, B, C, and the output lines are going to be what? 1, 2, 3, 4, 5, 6, 7, 8, right? And the corresponding variables are going to be Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Clear? Yes. Let's see how to implement. 3, 4, 5, 7. Where is 3? This is going to be 3 now. Where is 4? This is going to be 4. This is going to be 5. This is going to be 7, right? Such that these all guys are going to be implemented with the what? Which gate? We have to use NOR gate. That is going to be total output. Any doubts now? No. In the same way, we can also implement the circuit with the help of what? Active low output. Now, I hope things are very clear to you all, right? So let us design. This is all about decoder circuit, right? And everything we have seen, implementation also over, right? So next we have to design encoder circuit, right? So let us see how to design the encoders. So let me rub this one. Let us design the encoder circuit. Yeah. Almost we are in the edge of 50% of the digital electronics, right? It's over. I can say 60, more than 60 also, because only 2 more topics are pending, right? We can complete because they are small topics only. Fine. Next, we should talk about what? Let us design encoders. Let us design encoders, right? Now, how will you do this one? See, encoder in the sense, the general circuit is what? Anyway, we know regarding the informations I had given already. We are going to consider 2 power n cross n. That is the total number of input line and output line with the what? Once again, enable pin. Now we know the enable data, right? That is the information regarding this enable pin, right? So let's start our journey. From the input line, we are going to consider 2 power n combination. This is going to be our input. And whereas in the output line we are going to consider only n combination, and this is going to be our output, right? Let us see what happens now, right? So this is our encoders, right? In this encoder circuit, what we have to do, we have to implement the circuit, right? So let's start our journey. Let's consider once again. See, I don't want to go up with the n equal to 1. That's very small. Let's consider n equal to 2. Better. N equal to 2 in the sense, how many input lines should be required? 4 input lines, right? So let us implement 4 cross 2 encoder, 4 cross 2 encoder circuit, right? So 4 cross 2 in the sense, totally 1, 2, 3, 4. 4 input lines should be required. and two output lines should be required, and this is going to be our enable pin, right? And two outputs in the sense either, that is we are going to consider y0 and y1, and four inputs in the sense we are going to consider what, i0, i1, i2, i3, right? So let us consider informations are i1, i0, that is i2, i3. Totally we are going to consider four output lines. So our next target is we have to achieve the outputs, right? So let us see, let me do this one in terms of a truth table. You will get the clear idea, right? Anyway, let us consider truth table. First we should consider enable pin, and then we have to consider four input combinations. One, let us consider two, and then we have to consider three, and then I have to consider that is fourth one, and then we have to consider output line. We are going to consider two outputs, right? So let us see the possibilities of this one, right? Let us see the possibilities. Now the thing is what, first we should consider enable pin, and then I should talk about input line i0, i1, i2, i3, and then we should talk about output possibilities y0 and y1, right? So first of all, if enable pin is 0, if enable pin is 0, it indicates your circuit is in inactive state. In inactive state, right, all your inputs are going to be 0 because we are not passing any electrical signal, and outputs are simply called don't care. I don't need to bother about them, right? So let's consider when enable pin is going to be 1, automatically see there are four possibilities, right? So from the input side, see, for the first thing is i0 is going to be enabled. When i0 will be enabled, then output is automatically going to be 0 0, right? And rest of input pins are going to be, we are just making it as 0. Now let's rise, enable pin is 1 only. Now i0 is going to be disabled, i1 will be enabled. Automatically what will happen, output combo is going to be 0 1 now, right? Let's consider enable pin is 1 only, input lines are going to be 1 0, such that rest of sorry guys, sorry, third pin will be enabled, i2 will be enabled, rest of pins are going to be 0, such that output is going to be 1 0. See that enable pin is 1 only, all pins will be disabled, i3 will going to be enabled, automatically output will become 1 1. When i0 will be enabled, output will become 0 0. When i1 will be enabled, output will become 0 1. When i2 will be enabled, output will become 1 0. When i3 will be enabled, output will become 1 1. Clear? So that is called what? Encoder circuit. Shall we implement? Yes. So let us discuss about implementation. So our next target is we have to implement the circuit, that is simply called implementation, right? So let us raise the question against implementation. How do I implement the circuit? So in order to implement the circuit, first we need enable pin, and then we should talk about the pin i0, and then we need i1, and then we need i2, and then we need i3. So totally we need what? 4 pins. i0 should be required, i1 should be required, i2 should be required, i3 should be required. What is our next target? Let's see, right? So first target is, see, output y0. Listen guys, so the output, let me first write down the function. y0 is equal to what? y0 is, see there, in the output of the y0 we are receiving 2 minterms now. So its correspondent inputs are going to be, see there, in order to engengla ungalku minterm varudho, that is output 1 varudho, that is its correspondent input we have to consider. Correspondent inputs are what? Its correspondent inputs in this line, enable pin is E, and with its output values are going to be what? i0 is 0, we have to take complement, i1 also 0, we should take complement, i2 is 1, and i3, for i3 we should take complement, correct? Plus I am getting one more minterm, its correspondent enable pin is there, and then i0 we should take complement, i1 we should take complement, i2 we should take complement, for i3 we no need to do anything, right? We don't need to do anything, right? So it's simply, now you can reduce the function here. Now what can we do now? See, first we have to consider all these people, and then we have to consider all these people. Let us see. First of all, enable pin E, that is this is y0. Similarly, you can also write the expression for y1. For y1 also we have what? 2 possibilities, right? So let me write first. So y1 also having the possibility, right? So y1 is what? This is the first minterm, its correspondent inputs are going to be enable pin, right? With i0 is 0, of course, i1 is enabled, of course, i2 is 0, yes, i3 also 0, such that plus i3 0 means we should take complement, right? Yes. Let us discuss about the second minterm 1, its correspondent value is enable pin, and i0 I should take complement, i1 I should take complement, i2 I should take complement, i3 no need, that is 1 only. Shall I implement them? You know how to do that one, right? So let me draw the i0 one, right? So i0 is what? So we should do one thing, that is enable pin. Of course, that is going to be the enable pin, and then that's what I've been told you. See, if I'll consider one inverter here for each and every line, if you are considering one specific inverter, let me consider this is i0, let us consider this is i1, let us consider this is i2, yeah, this is i1, right? i1, and this is going to be i3, such that with this I'm just requesting all to consider some inverters. Yeah, let me do one thing. Yeah, just to draw the inverter, and here also just to consider one inverter line, just to draw the inverter line, and then here also let's consider one inverter line. So circuit implementation will become easy such that, right, cost will be minimized. That is what I want. Unnecessarily we don't want to waste our cost, right? That is how we are implementing the circuit. Let's see what our journey with this, right? So we should take yeah, that line is going to be like this. That is our enable pin, right? Yeah, fine. So next, what is our target? I made of I naught bar, I1 bar, I naught bar. This is I naught bar, this is I naught bar. Next, I made of I1 bar, this is I1 bar, this is I1 bar. Next, I made of I2 we can take directly from here. Yeah, I think I'm in need of I3 bar, right? I3 bar. And then I should join this all people with the AND gate, right? We are going to multiply them, this whole combo. Similarly, we have to talk about the second person, E into I naught bar, I1 bar, I2 bar, right? So let us see, where is E? This is E. Of course, this is going to be E now, this is going to be E. Next, we should talk about what? See, better choice, you can keep this enable pin in this side such that this much of lengthy wire does not required for us. Again, cost will be minimized, right? So just to keep this enable line this point, directly we can take, right? Fine. Next, what I have to do, I naught bar, I1 bar, I2 bar. I naught bar, we should take the line from here. Yeah, I naught bar, I'm in the I1 bar, right? So this is going to be, let's see, am I correct? Yes, that is going to be I1 bar, and I'm in the I2 bar. This is going to be I2 bar, and I'm in of I3. This is going to be I3. So let's join them together such that this is going to be the output. See, this is not over yet, and then we should connect them. See, we have to do perform addition. After completing this one, they will be joined with the OR gate such that this is going to be the total output. Let me call it as Y0, right? Yeah, that is your actual output. Now I am giving small task to you all, just to lengthen the wire, right? That is, sorry, just to increase the length of the wire. Do the same thing for Y1 also in order to complete the circuit. Do it, don't leave that one. Just to increase the length of the wire, complete the second one also. That is how we are implementing the encoder circuits. I hope things are very clear to you all, right? Now, did you notice one thing? Let us see the drawback of the encoder. Listen guys, actually the drawback is, இங்கே என்ன பிரச்சனை அப்படின்னா, ஃபார் எக்ஸாம்பிள் எனக்கு இப்போ நம்ம வந்து 4 டைப் ஆஃப் ஐட்டம்ஸ் வந்து சும்மா அண்டர்ஸ்டாண்ட் பண்ணிக்கோங்க. இப்போ நமக்கு வந்து ஒரு சிஸ்டம் இருக்குது, அந்த சிஸ்டமில் வந்து 4 டைப் ஆஃப் டேட்டாஸ் ஃபுட் வந்து நம்ம ரிசீவ் பண்ணோம், ரைட்? ஸோ லெட் அஸ் டேக் ஒன்ஸ் அகைன் பீஸா வில் பி தேர், ரைட்? பீஸா, பர்கர் வில் பி தேர், and then I'm in need of some chicken, that is chicken rice and vegetable rice. Let's take some 4 type of foods here, right? So pizza will be there, or we can take pasta, whichever things that you want you can keep, right? So pizza will be there, burger will be there. Let us consider some chicken rice or vegetable rice at all, right? So let's consider what shall we do now. The thing is, listen, now I would like to receive pizza. எனக்கு வந்து இப்போ பீஸா தேவைப்படுது, ரைட்? ஐ வுட் லைக் டு ஹீட், ஐ வுட் லைக் டு டேக் பீஸா. அப்போ பீஸா வந்து நான் எடுத்துக்கணும் அப்படின்னா ஐ ஹாவ் டு எனேபிள் I0 எனேபிள் பண்ணால் ஆட்டோமேட்டிக்காக என்ன வரணும்? பீஸா வந்து டெலிவரி ஆகும். நான் இப்போ இங்கே என்ன ஆயிடுச்சு அப்படின்னா, தெர் வாஸ் சம் மேல் ஃபங்க்ஷனிங் இன்சைட் தி சிஸ்டம். அப்போ மேல் ஃபங்க்ஷனிங்கால் என்ன ஆயிடுச்சு அப்படின்னா, சடன்லி தி ப்ராப்ளம் இஸ், see there I0 is being enabled here. இனிஷியலாக என்ன ஆயிடுச்சு அப்படின்னா, தி வெரி ஃபர்ஸ்ட், ரைட்? வெரி ஃபர்ஸ்ட் என்னன்னா எல்லாமே வந்து, ஸோ ஓகே லெட்ஸ் டூ ஒன் திங், திஸ் இஸ் பீஸா. பீஸா வந்து இங்கே பர்ஃபெக்டாக டெலிவரி ஆகுது. ஏன்னா பீஸா வந்து ஃபஸ்ட்டு நீங்கள் அப்போ தான் ஆக்டிவேட் பண்ண போகிறீங்க. எல்லாருமே இன்ஆக்டிவ் இருக்காங்க. நீங்கள் ஆக்டிவேட் பண்ணோன்னே ஃபர்ஸ்ட் பின் இஸ் கோயிங் டு பி எனேபிள்ட் சச் தட் பீஸா வில் பி டெலிவர்டு பர்ஃபெக்ட்லி. Next, what happened? இப்போ அடுத்ததாக வந்து one of my friend is coming here and usually he is not taking non-veg, right? So he is to take veg. அப்போ அவருக்கு வெஜ் வந்துட்டு அவர் என்ன பண்ணுறாரு அப்படின்னா, he is choosing inputல I2 வந்து எனேபிள் பண்ணுறாரு. அமௌண்ட் வந்து பே பண்ணிட்டு கார்டு ஸ்வைப் பண்ணிட்டு ஸ்மார்ட் கார்டு, ரைட்? ஸோ he is using a digital card. He is trying to what? Swipe in order to get the vegetable rice. Now the problem is, அப்போ வெஜிடபிள் ரைஸ் உங்களுக்கு அவுட்புட்டில் ரிசீவ் ஆகணும் அப்படின்னா I2 will be செலக்ட் ஆகணும், கரெக்டாக? நான் while selecting the output, see there already இதுக்கு முன்னாடி பார்த்தீங்கன்னா, இதுக்கு முன்னாடி வந்தவர் வந்து யார் யார் வந்திருக்காங்க அப்படின்னா, I came first, right? And I enabled I0 such that I used to take what? Pizza. One more person came, right? And that person enabled, அவர் என்ன பண்ணியிருந்தாருன்னா I1 யூஸ் பண்ணியிருந்தாரு in order to take what? Chicken rice. எடுத்துக்கிட்டு அவர் போயிட்டாரு. Now the problem is, இங்கே என்ன ஆயிடுச்சு அப்படின்னா, தேர்ட் பர்சன் வந்து எனேபிள் ஆகிட்டார். தேர்ட் பர்சன் வந்து எனேபிள் ஆனதுக்கப்புறம் ப்ரீவியஸில் நம்ம ஆல்ரெடி என்ன பண்ணியிருக்கோம், இந்த 2 லைன் நீங்கள் யூஸ் பண்ணியிருக்கீங்க. Do you all agree with me? See there, already this line I had been used here. I took, right? I had been, that is I took what I can say pizza by enabling this pin. One more person came, right? He took chicken rice with the help of what? That is by enabling I1. The problem is, when I am enabling this one, if there is any malfunctioning, suddenly நான் வந்து I2 தான் enable பண்ணணும் if there is any malfunctioning because already previously வந்து இந்த ரெண்டு கேட்ஸ் வந்து நீங்க என்ன பண்ணிருக்கீங்க ஒர்க் பண்ணிருக்கீங்க இது கூட ஒர்க் பண்ணிருக்கீங்க இப்போ அது ஒர்க் பண்ணதுக்கு அப்புறம் அது ப்ராப்பரா டீஆக்டிவேட் ஆகல அப்படினா automatically malfunctioning will be possible here that malfunctioning will going to see there I2 மட்டும் enable ஆனாதான் எங்க கோட் என்ன ஜெனரேட் ஆகும் according to the generation according to coding நீங்க என்ன டைப் பண்ணி வச்சிருப்பீங்கன்னா 0010 enable ஆச்சுனா அவுட்புட்ல வந்து என்ன ஆகணும் vegetable rice வந்து டெலிவரி ஆகணும் that is what you are coding இப்போ என்ன இருக்குன்னா due to some malfunctioning it has become 1. Can you deliver? No, your system is stuck. It will struggle, that is it will trouble, it is unable to deliver because அதுக்கு என்ன தெரியாதுன்னா இந்த மாதிரியான ஒரு கோடிங்க்கு எந்த ஒரு ஃபுட்டையும் டெலிவரி பண்ண சொல்லி நம்ம எதுவும் ஆக்ஷன் கொடுக்கல so it's simply waiting what shall we do now because we don't have இந்த மாதிரி ஒரு கோடிங் நம்ம கிட்ட கொடுக்கலையே it's waiting என்ன ஃபுட் டெலிவரி பண்றதுன்னு தெரியாம your mission is it's at a stuck right so what is the conclusion here we have to avoid this type of malfunctioning in the malfunctioning எப்ப நடக்கும்னா see there actually the problem is from the input line we are using 4 lines right 4 lines in these 4 lines at a time see there I0 enable இருக்கும்போது remaining இருக்க 3 pins வந்து disable இருக்கு when we are enabling I1 remaining 3 pins will be disabled when we are activating I2 remaining 3 pins will be disabled when we are activating I3 remaining 3 pin will be disabled but the conclusion is what but the conclusion is with the help of these 4 people we can create 16 combinations do you all agree with me கரெக்ட் தானே இந்த 16 காம்பினேஷன்ல நீங்க எத்தனை காம்பினேஷன் யூஸ் பண்ணிட்டு இருக்கீங்க only 4 காம்பினேஷன் சோ ரிமைனிங் இருக்க 12 காம்பினேஷன் உள்ள என்டர் ஆக கூடாது are you getting me இங்க 4 inputs line இருக்காங்க 4 input lineல அதாவது 4 bits வச்சு we all know with the help of 4 bits right we can create what 16 combinations we know the number of possible combinations we can go up with the 00000100011001100 like that we can create 16 combinations with the help of 4 input lines so the problem that I have understood here out of these 4 combinations if I'll find if your system with the malfunctioning if it will select some other type of combination automatically your output will be disabled your system is right it will be troubled to deliver the correspondent output so the problem is what in the remaining இருக்க 12 data சால எந்த ஒரு இஷ்யூஸும் வராம பாத்துக்க வேண்டியதா உங்களோட டார்கெட் right so that is called priority encoder clear so in order to avoid the what I can say malfunctioning of the system we are moving on to the next type is called what priority encoder I hope things are because I need to see எனக்கு chicken rice வேணும் அவ்வளவுதான் my friend is waiting I don't take chicken right so my friend is he is waiting for chicken rice right so the thing is what I'm just I got what burger right so I'm just I pizza right I'm using I'm taking pizza he want what chicken rice he is waiting for that இந்த ஃபுட் தான் கரெக்ட்டா எனக்கு டெலிவரி ஆகணும் I don't want to let the system to trouble right for that perfect mission we have to design the perfect encoder கோடிங் வந்து பர்ஃபெக்ட் ஆகணும் என்கோடிங்னா ப்ராப்பரா வரணும் ரைட் அந்த ரிமைனிங் இருக்க 12 காம்பினேஷன்ஸ் வந்து நம்ம டீசெலக்ட் பண்ணி வைக்கணும் அதாவது அந்த காம்பினேஷன் வந்தாலுமே சிஸ்டம் வந்து என்ன ஆகக்கூடாது ஃபீல் பண்ணக்கூடாது ஓகே அப்படி வந்தாலும் அது கரெக்டா ஒர்க் ஆகணும் தட்ஸ் வாட் அவர் டார்கெட் நோ ரைட் ஸோ that is called what priority encoder right so such type of encoder is simply called priority encoder right let's see so next we are going to discuss about priority encoder priority will be given right so let's see how we are going to design the priority encoder so the priority encoders are let's select the same possibilities right I'm not going to discuss any new things let me raise n equal to 2 once again let us design the same encoder it means we have to consider 2 possible bits okay I think I took n equal to 4 possible inputs sorry 1 2 3 4 correct such that I0 I1 I2 I3 we are going to get right now its correspondent outputs are going to be what Y0 Y1 exactly that is correct right now with this we are going to consider the enable pin also of course fine now what we have to do I had a problem anyway we are in priority encoder now you don't need to be panic right we are in priority encoder right so this is priority encoder yeah so don't much bother now priority encoder enna padudhu paakalama let's see once again let's design the truth table first one thing I need enable pin and then we need 4 input lines 1 and 2 3 4 we should need that is I need of 2 output lines also right so let's join them together let us see right how to bring the output right yes See, this is going to be enable pin, and from the input line we have 4 combinations. I0 will be there, I1 will be there, I2 will be there, I3 will be there, and Y0 will be there, Y1 will be there. Okay, let's see. இப்போ நம்ம என்ன பண்ண போறோம்னு பார்க்கலாமா? இப்போ நான் என்ன பண்றேன்னா enable pin first 0 இருக்குங்க. enable pin 0 இருந்தா என்னங்க நடக்கும்? enable pin 0 இருந்தா output don't care. அதுல எனக்கு ப்ராப்ளம் கிடையாது, right? Now what I am going to do, let us see. The second thing is system activate பண்ணியாச்சு. enable வந்து நம்ம 1 ன்னு செட் பண்ணியாச்சு, right? Yeah, that is enable active, right? So that is active enable pin. Now the thing is what, that is active I enable pin actually, right? So this is 1 அப்படினா automatically see there. ஃபர்ஸ்ட் நான் என்ன பண்றேன் அப்படின்னா I0 செலக்ட் பண்றேன். சிஸ்டம் நம்ம அப்பதான் ஆக்டிவேட் பண்ண போறோம். இது வரைக்கும் எந்த ஒரு இன்ஃபர்மேஷனுமே கிடையாது. அப்ப என்ன நடக்கும் அப்படின்னா கண்டிப்பா டோட்டல் வேல்யூ வந்து செட் பண்ணி வச்சிருப்பாங்க, 0ல தான் இருக்கும். அப்போ மேல் ஃபங்க்ஷனிங் வராது. ஏன்னா சிஸ்டம் இது வரைக்கும் நம்ம எந்த ஒரு ப்ராசஸிங்குமே பண்ணல. அண்ட் தி பியூட்டி என்ன அப்படின்னா சிஸ்டம்ல மெமரி இருக்காது. அதனால நீங்க வந்து ஃபாஸ்ட்டை பத்தி வரி பண்ண தேவையில்ல. சின்ஸ் we are in what combinational circuit, in combinational whichever the system that we are designing, that system has no memory, right? Fine. So the thing is what, when your I0 will be enabled, automatically happily I am receiving pizza. That's what my intention. நான் போயிட்டு pizza வாங்கிட்டு வெளில வந்துட்டேன். Now I am just sending my friend, right? Now what he is going to do, அவனுக்கும் ப்ராப்பரா வந்து சிஸ்டம் வரணும் இல்லையா? I mean ஒர்க் பண்ணணும். Anyway, he is used to it, that is he is he would like to take chicken rice, right? So let's see what happen. அப்ப enable pin is active. Now guys listen. இப்போ நீங்க எப்படி கோட் வந்து கோடிங் டிசைன் பண்ணோம் அப்படின்னா, ஃபார் எக்ஸாம்பிள் நான் சிக்கன் ரைஸ் வந்து எங்க இருக்கு அப்படின்னா I1 டேபிள்ல இருக்கு. I1 டேபிள். அப்போ நான் ஃப்ரண்ட் என்ன பண்ணுவார் அப்படின்னா I1 வந்து ஆக்டிவேட் பண்ணுவார். சச் தட் ஆட்டோமேட்டிக்கா என்ன ஆகும், திஸ் இஸ் கோயிங் டு பி சிக்கன் ரைஸ் வந்து அவருக்கு இமீடியட்டா டெலிவரி ஆகணும். 01 is the correspondent coding. அப்போ என்ன ஆகும் அப்படின்னா see there guys listen. ஆல்ரெடி நம்ம ஏதாச்சும் ஒரு லைனை யூஸ் பண்ணியிருக்கோமா? எஸ், I0 is already being in use. அது வந்து ஆல்ரெடி யூஸ் பண்ணியிருக்காங்க. பட் திரும்பவும் இந்த I0 இந்த இடத்துல ஆக்டிவாகவே இருந்தாலும் என்ன பண்ணணும், அதை பற்றி இது வரி பண்ணக்கூடாது, ரைட்? நீங்கள் I1 செலக்ட் பண்ணும்போது உங்களோட சிஸ்டம் வந்து I1 enable அப்படின்னா இட்ஸ் correspondent food is what? Chicken rice. I0 is enabled, its correspondent food is what? Pizza. I3 is enabled, its correspondent like you can consider some pasta, burger, whichever things that you want, you can consider some other type of foods, right? So that just let us consider like this. அப்ப என்ன வரணும் அப்படின்னா நீங்க என்ன ஃபுட் ஐ மீன் கோடிங் செலக்ட் பண்றீங்களோ அதுக்கு கரஸ்பாண்டன்ட் சிஸ்டம் வந்து என்ன பண்ணும் அப்படின்னா வேற யாரை பத்தியும் வரி பண்ணக்கூடாது. தட் இஸ் கால்டு priority. Priority will be given to the enabled pin immediately. Rest of people are simply considered here, right? Priority will be given to the activated pin. Rest of person are simply called. It is called what? Already நீங்க யூஸ் பண்ணிருக்க லைனை பத்தி அது வரி பண்ணாது. That is called don't care now. Right? So anyway, still now we have not used these 2 pins, so there is no point of discussing about malfunctioning for them, right? So let's continue our journey. Again, one more person is coming, right? One more friend is coming there, and he used to take vegetable rice, right? So what he is going to do, I2, let us assume I2 is the vegetable rice line. What he has to do, அப்போ நம்ம என்ன பண்ணணும், அவர் கரெக்டாக I2 செலக்ட் பண்ணும்போது ஆல்ரெடி நம்ம யூஸ் பண்ணிருக்க சிஸ்டம் வந்து நம்ம கன்சிடர் பண்ணக்கூடாது. சிஸ்டம் டோன்ட் கேர், ரைட்? டோன்ட் கேர் அபவுட் தட் ஒன். விச் லைன் will be selected now? I2. Its correspondent food is what? Vegetable rice. Just deliver it, right? Such that what will happen automatically? Output is going to be 1 0. Fine. Again one more friend is coming now. What he would like to take pasta, right? Such that he is activating, that is he is not carrying pasta வந்து எங்க இருக்குன்னா I3 லைன்ல இருக்கு. இந்த லைனை நீங்க ஆக்டிவேட் பண்ணிட்டீங்கன்னா pasta டெலிவரி ஆகுது automatic, right? So when I am enabling I3, output is going to be 1 1. Rest of things are don't care. We are not considering rest of people. Happy now? Yeah. Do you have any malfunctioning? Of course I don't have any malfunctioning. எனக்கு இப்போ ப்ராப்ளமே வராது. நீங்கள் யாராக வேணாலும் இருந்துட்டு போங்க, எனக்கு பயம் கிடையாது now, right? So the conclusion is what? Simply we can deliver. The thing is, what is the conclusion now? So why not y1? So that's all. Without any malfunctioning, you can deliver the system. Now you can write the function for this. Like இப்போ நீங்கள் y0 க்கு என்ன possibilities எழுதுவீங்க? First of all, directly நீங்கள் எழுத முடியாது. Let me write the answer, right? So the thing is, summation of, let me put min terms. என்னங்க சம்மந்தமே இல்லாத போறேன்னு பார்க்குறீங்களா? லெட்ஸ் சி இங்கே என்ன வருதுன்னு பார்க்கலாமா? அங்கே பாருங்க, அவுட்புட் y0க்கு பார்த்தீங்கன்னா 2 மின்டம் வந்திருக்கு, கரெக்டா? எஸ். இப்போ இந்த மின்டமோட கரஸ்பாண்டன்ட் காம்பினேஷன்ஸ் பார்த்தீங்கன்னா யார் யார் இருக்கா? x10. லெட் மீ கலெக்ட் தெம் அவுட் சைட். x10. See, this is the correspondent input lines for this minterm. இந்த xs அப்படிங்கிறது, இந்த xx அப்படிங்கிறது யார் யாரா இருக்கலாம்? Either they might be 0 0, it might be 1 0. Or they might be 0 1, it might be 1 0, or they might be 1 0, it might be 1 0, or they might be 1 1, it might be 1 0. See there, I have 4 possibilities now. Now you can see this is what, it is the equivalent value of 2, and this is what, which is the equivalent, that is the equivalent value of 6, and 1 0 1 0, I think that is the equivalent value of 10 only, right? And this is the equivalent value of 14. clear. Similarly, let us consider the second midterm. அப்போ இங்கே யாரெல்லாம் கன்சிடர் பண்ண போகிறோம்? we are going to consider 2 6 10 11, right? Similarly, second midterm. இப்போ இதோட possibilities பார்க்கலாமா? I have x triple x 1. triple x 1 நிறைய பாசிபிலிட்டி இருக்கு இல்லையா? 0 0 0 1 இருக்கலாம், இல்லை 0 0 1 0 இருக்கலாம். சாரி, this is fixed, right? அதர்வைஸ் 0 1 0 1 இருக்கலாம், அல்லது 0 1 1 1 இருக்கலாம், ஆர் அதர்வைஸ் 1 0 0 கரஸ்பாண்ட் 1 இருக்கலாம், இல்லை 1 0 1 வித் 1 இருக்கலாம், இல்லை 1 1 0 வித் 1 இருக்கலாம், இல்லை 1 1 1 வித் 1 இருக்கலாம். கரெக்டாக பாசிபிலிட்டி பார்க்கலாமா? இங்கே யார் இருக்கா? தட் இஸ் 1 ஒன்ஸ் அகைன், அண்ட் திஸ் இஸ் கோயிங் டு பி 3, திஸ் இஸ் 5, திஸ் இஸ் 7 ஆக்சுவலி, அண்ட் திஸ் இஸ் கோயிங் டு பி 9, அண்ட் திஸ் இஸ் கோயிங் டு பி 11. Yeah, that is 11 only, I think I am correct, and 11, and then this is 12 13, I think. Yeah, that is 13, correct? 1101 and then 110. Yeah, I am correct, and this is going to be 15. So totally how many possibilities are there? So we are going to consider 2 comma, and then sorry, 1 also there, na 1 comma 2 comma 3 is there, and then 5 is there, and then 6 is there, and then 7 is there, and then 9 is there, and then 10 is there, 11 is there, and then 13 14 15 is there, right? So 13 14 15 is there, right? Now how will you reduce this function? You can just put it in the K-map, like so. You can just this is the total output variables of the possible outputs of the y0. My second task is just to take the y1, repeat the same thing that I have done. See, just to learn the subject, this is not, you don't need to take proper notes. I'm not supposing you all to memorize anything here, right? Blob story does not require in digital electronics, right? The thing is, once you have to understand, then you can play with the circuit, right? So the thing is, the second task is take this one, take K-map. K-map la eppadi implement பண்றது உங்களுக்கு யாருக்கும் தெரியும் இல்லையா? So the thing is, K-map in the sense, see, just consider all these variables, we have to put it in the K-map, right? So K-map la போட்டு automatically you can complete, that is draw the என்ன பண்ணலாம், இது correspondent boolean expression உங்களுக்கு கிடைக்கும். You can just implement it into the logic circuit. I hope things are very clear to you all. That's there are no big things to discuss, right? So this is all about priority encoder, right? So I hope now you don't have any doubts, right? So this is all about encoder is completely over, and what I can say, priority encoder also completely over, right? And so guys, a small task, just implement same way you have to do for y1, right? So y1 க்கு என்ன பண்ணுவீங்க? இங்க 1 வந்திருக்கா, its correspondent possibilities. இங்க x இருக்கு இல்லையா, x 100 இருக்கா, அப்ப x க்கு பதிலா என்ன பண்ணலாம்? Either I can consider 0 or I can consider 1. There are two possibilities. So 0 100 means 4. 100 in the sense what? That is 1100 12. That is equal to 12, right? So there are two possibilities here. Similarly, here I had one more midterm for y1. Coming back, so there are how many possibilities are there? Triple x equal to 1. We saw all the possibilities already. See there, 9 11 13 15 1 3 5 7. These are the possibilities for this one. Same midterm, right? So in the midterm already I have written here, right? So just to consider all these terms, put it into the K-map in order to obtain the correspondent boolean expression offered by the y0 and y1. யாரை consider பண்ணுவீங்க? Input line we should select from MSB I0 I1 and then I2 I3, right? K-map la போட்டிங்க அப்படினா automatically you get the boolean expression, and then you can implement into the circuit, right? Just understand, try it, because already we had been implemented many circuits, na? Yes. So these are all your basics, right? With this that is almost we are in the edge of your combinational circuit. Until we should talk about some parity checker and generator, some small basics, right? It should be required in order to get the clear idea about what I can say combinational circuit. Almost it will be over, right? Tomorrow I will conclude those that is a small circuits, right? And then we will solve some numerous problems. Immediately we are moving on to the next chapter, that is the phase 2. Completely almost 60% of the digital is over. Next we should talk about, that is we have to start what I can say sequential circuit, right? So that is the beautiful chapter. With the memory we are going to design the circuit. I hope things are very clear to you all, right? If you have any doubts, you can raise the question in our group, right? So with this, let's wind up the class. Thank you all.